Let's get started, people. Okay, everyone, we're going to go ahead and get started today. Thank you so much for coming out to the Route Cut seminar series from the Institute on Ecosystems. This is our last one for the semester. So we'll resume again starting in January in a different location to be determined, to be announced. But I have the pleasure of introducing our speakers for today, Kristin, Legg, and Andrew Ray. So I'll give a brief introduction to each of them. Kristin Legg has served as the program manager for the Greater Yellowstone Network since 2011. Prior to this position, Kristin was Chief of Cultural and Natural Resource Management at Zion and Bryce Canyon National Parks and Pipestone National Monument. Kristin received her MS in Fish and Wildlife Management from here at MSU, actually, and studied the habitat use and movements of bighorn sheep in the Gallatin Mountains. And Andrew Ray is an ecologist with the Greater Yellowstone Network, and he has his PhD in Biological Sciences from Idaho State University, Master's of Science from Northern Michigan University, and his Bachelor's of Science from Purdue University. Prior to joining the Greater Yellowstone Network, Andy worked with the U.S. Geological Survey and at the Crater Lake National Park Science and Learning Center. Let's give a round of applause for the both of them.
Great. So thanks all for coming. This is a great turnout, and we're really looking forward to giving our presentation. It's more of an overview of who we are and what we do versus any specific details, and we'll go ahead and get started. So this is just kind of the overview. We'll be talking about what vital signs monitoring is, who we are as the Greater Yellowstone Network, what we've learned and how we're using that information or how this information is being used, and kind of the big picture, kind of stepping back and looking at what matters as we move forward. So we want to recognize that we're not alone in doing the work that we do, that we have a lot of collaborations and partnerships, both working with the parks that we help do the inventory and monitoring, or we do the inventory and monitoring work. There's similar networks like us that we collaborate with. We work with non-government agencies such as the Northern Rockies Conservation Cooperative out of Jackson Hole, the Colorado Science Partnership,
Natural Heritage Program.
Natural Heritage Program. What's this?
Oh, CSP, Conservation Science Partners.
Science Partners. Walking Shadow Ecology, who's an individual, Dr. Mike Tersick, based out of Gardner, Montana. Universities, you can see that we're doing this in collaboration with many folks.
Okay, so we want this to be as interactive as possible too. So if you have any questions as we go through, please raise your hand, and we'll try to answer your questions. So central to understanding human health is regular or routine monitoring of vital signs, right? So we're talking about monitoring our blood pressure, our heart rate, monitoring our weight. These sort of standardized, routine, regular measurements are key to understanding human health. We understand there's natural ranges of variation within humans, but this sort of serves as the basis for monitoring ecosystem health as well. And just like there's periodicity in some of the measurements that we do for humans, so again, heart rate or blood pressure, there's some periodicity. There's also periodicity in nature, right? So snows fall, and over the fall and winter, we get runoff, we get subsequent green up, and then animals are following that green wave. So there's periodicity in nature too. And our monitoring is doing its absolute best to design protocols around that periodicity and then try to characterize changes in that through time. And there's a lot more eloquent speakers out there in the National Park Service than me. But Cam Shawley, the new superintendent, I think said it really well. And he said, scienceless decisions are the fastest way to the impairment of National Park Service resources. So as National Park Service scientists, our charge is to deliver scientific information acquired through monitoring to park management so they can make decisions based on that information. So what are some of these indicators that we use? Well, some of the physical and chemical indicators are air temperature, snowpack depths, stream flows, water and snow chemistry, and soil moisture. But we also use biological indicators or biological sensors, if you will. And there's lots of different types of indicators. We use both common and rare species. Our goal is to keep common species common in parks. Those are easier to track. It's hard to track rare species. And any of you who have done a lot of biological work, survey and monitoring work, understand that. But some parks use flagship or iconic species. They'll use pikas or grizzly bears because those are the things people are aware of and care about. But also proxies or sentinel species. So we use things like amphibians as a proxy for understanding climate change.
All right, so kind of understanding that foundation, and the Park Service has been around well over 100 years, and with the formation of Yellowstone National Park in 1872. And so while there's been science in the background, and in places like Yellowstone, Glacier, these larger parks have really good science programs, the Park Service recognized that there needed to be more. And leading up to the decision to form like the inventory monitoring program, we had the first scientific surveys that were conducted, kind of our first inventories in the 1930s by George Melendez Wright. And then over time, it kind of ebbed and flowed, and there was a lot of information going in. So like the Aldo Leopold report, formation of the natural resources study, so our first formation of a department focused on natural resources in the National Park Service, were all happening in the 1960s. And then it kind of became apparent that more needed to happen in order to provide better science for parks to make decisions. And in the 90s, that ball really started to roll, and there was these long-term ecological monitoring prototypes that were established to kind of test this. How would this work over the long term? And there were 7 of those that were formed. And then in 1999, with a big push out of a number of National Park Service key employees, that they actually were successful through Congress in getting a large funding package together. It was called the Natural Resource Challenge. And out of that, there were parks got resource staff to come in, but the formation of the inventory monitoring program starts. And there's 32 networks across the ecosystem, and the networks are composed of parks that are ecologically similar and somewhat close to each other to help facilitate getting the work done. These networks came on at different times. We were fortunate to start in 2000. So the Greater Yellowstone Network was one of the first ones to get going. And now we're looking 20 years later, we're looking at our 20th anniversary. So we're relatively new in the scale of the National Park Service, but it's pretty awesome because now we're able to start to tell stories from the work we've done over the past 20 years. And this was just to kind of give you an idea of the parks that are coming on board. So like the Greater Yellowstone Network works in Yellowstone National Park, Grand Tetons, Bighorn Canyon, and the John D. Rockefeller Jr. Memorial Parkway. I added some of the other parks in the state of Montana just to give you an idea of when those parks were established.
So as Kristin's pointed out in this map, our group works with clusters of biologically similar or ecologically similar parks. So we're here and we work with 4 park units. Just notice the scale of some of these other networks. Some of them have 10s,
14, 16, yep.
20 parks, and they cover very long distances. So we're sort of fortunate here in the Greater Yellowstone ecosystem to not have to travel too terribly far, or like our friends who are based in Atlanta, they have to get up and drive in the middle of the night to get to their field sites just so they don't get stuck in traffic. So anyway, here we are in this sort of sea of NPS park units.
And that's a great point that builds off of like the Yellowstones, the glaciers have these great science programs already, but a lot of the parks, the majority of the parks are very small, and they might have a resource staff if they're lucky. And so this inventory and monitoring program, along with regional office staff and all, help those parks be kind of their resource staff. So it was also recognized the importance of, there was a thought, well, just give the money to the parks. And a very smart decision was made in not just turning the money over to the parks, because it would just kind of, it would get consumed by the parks over time, and to actually look at this network scale across an ecological system. And so as we look at that, the Greater Yellowstone Network with those 4 park units, but then it gets scaled up to like the Intermountain region, of which has 7 networks total, and then across the country. So the information starts flowing at a different scale than just within an individual park. And you can see this kind of growth model. So when we first got started, we were very focused on the parks that we were responsible for. But over time, as we start to grow, we start to gain information, the other networks are starting to grow too. We start to look for opportunities for overlap, sharing information, both within and across networks, across parks, and across regions. Anything else? So looking at just specifically our history, the Greater Yellowstone Network history, and how we got our protocols or our vital signs on board, is that we were established in 2000, 2001. We're called inventory and monitoring. One of the very first things out the gate was to figure out what we have in the parks, so our inventories. And those were started in 2000 and went up. We finished our final one with a vegetation map in Bighorn Canyon in about 2011 or 12. And then there was a vital sign selection time period. So from 2000 to 2005, the network staff worked with park staff and specialists from the region to figure out what should we be monitoring. And again, you can imagine in a place like Yellowstone, they do a lot of stuff already. So what are the things they're not paying attention to where the network could help figure out what's happening? And also in Grand Tetons and Bighorn Canyon, it was similar, Bighorn Canyon being unique because it is a little bit smaller in scale. So we monitor kind of 6 things total. We have whitebark pine, which was one of our first protocols or vital signs we started in 2004. This one's unique in that we don't only monitor in the parks, we actually monitor across the Greater Yellowstone ecosystem. So that includes Forest Service and BLM lands. In 2005, the water quality and amphibian wetland protocols, vital signs come on board. Gloria Alpine is 2011 with a site up kind of on the east boundary of Yellowstone. And then the vegetation, upland vegetation monitoring was staggered in from 2011 to 2015. And that occurs in all 3 park units. Meanwhile, climate is coming, climate's happening all the time. And we were able to also start monitoring or paying attention to that and how it fits into all of our other vital signs in the parks, really in the late 2000s onward. A key thing that is unique, again, to the INM program, and one of the key points that was made when we were established, is the need to make sure we're doing good data quality management, so good data stewardship, and recognizing that a lot of work that gets done is often done on individual computers, it's saved on those computers, it's put into file drawers. We put 30% or more of our time into data stewardship to ensure that our data is managed and out there for the public and available to the public. So I'm looking at Rob, our data manager. He has anything else to say? Yeah, which is kind of a really cool and unique thing for us.
I wanted to clarify one thing. So we are government employees, so we are subject to using some jargon. So we're going to say protocol a lot. Yeah. Protocol is just a recipe for how we study different vital signs. So we have a recipe for how we study whitebark pine and a recipe for how we study water quality. We're going to use that interchangeably with protocol. But I just wanted to clarify that point.
Yeah, thank you. So we'll just jump into an overview now of our vital signs. And it's just, we won't go into the details of what we do, but some of the highlights of those, what we've learned over the time period. So again, we've been monitoring whitebark pine since 2004. It takes us 4 years to visit all the sites in the ecosystem. So every 4 years, we're able to do a kind of state of what we know and start tracking trends over time. So between when we started 2004 to 2015, we're looking at blister rust infection rates, and we haven't seen a change over time. So they're statistically the same in those 3 monitoring periods. We're gearing up to do our 4th visit. So hopefully within a year we'll know if we've changed or not. Same with tree mortality in all size classes. It's about 30% between that time period. And this is unique. So a lot of us have heard about the massive die-off of whitebark pine in the ecosystem of like 80%. And those are those large trees, those beautiful trees like this that are cone bearing. And we find similar responses of mortality in that size class, but we're looking at small trees on up to big trees. So we have a 30% die-off in the ecosystem. Tree mortality from mountain pine beetle, when we started digging into that information, trying to figure out what trees were more likely to die or not, the trees that were found in sites that had more water available or a higher evapotranspiration were less likely to die during a mountain pine beetle attack. And that we also, during an outbreak, there was no interactive effect between mountain pine beetle and blister rust. Basically, the mountain pine beetle during the outbreak was just so massive that it didn't matter whether a tree was infected or not with blister rust. And then we've also just recently looked at like thinking about now what's going to happen to those trees left on the landscape and their likelihood of being infected by blister rust. That trees that are larger trees that are found in warm and humid condition sites, those sites that are more likely to be infected are more likely to be infected. And so this map is kind of mapping the infected trees, non-infected trees, and the probability of infection in the greater Yellowstone.
One interesting little anecdote on this that's non-science related, but interesting for people to hear. Our crews who do whitebark pine surveys climb the equivalent of 4 Mount Everests a season. So those folks are in shape.
Yeah. So upland vegetation, again, which happens in all three parks, is just, we've been doing that since about 2011 in Bighorn Canyon and 12 in Grand Tetons, and those are the 2 parks where we're really spending the time looking at the This is a true collaboration with Yellowstone and Grand Tetons. So Yellowstone leads the monitoring effort. They're the ones managing the data. We help house the data and they follow our protocol. Tetons is a little bit more of a sharing opportunity. So we don't have data from Yellowstone because they're in the process of analyzing that right now. In our most recent research or study or analysis from Grand Tetons, we're not seeing any change over time. So this graphic here is an ordinational analysis, and these are the different years for one of the frames that we visit. And you can see that it just hasn't really changed, which is that's kind of what we would expect, because vegetation changes more slowly unless we were to have like a fire on the landscape or some big kind of stochastic event. The other thing that's really cool is that the data is available through an online website called vegviz.org. And out of that, we can look at map presentations of the frames and figure out where, for instance, like mountain mahogany is occurring within this frame and the percentage it occurs, the cover of that percentage, or cover that it occurs in the frame. And then also you can do it graphically as well. And when we talk about frames, in Bighorn Canyon, we have 10 geographic areas that we go to. And of those areas, we randomly select points and do the cover class or do like what percentage of vegetation is in those points every time we go to that site. So we're going over a allotted area instead of like a single line transect, which many people are familiar with for vegetation sampling. We're covering a large unit. And then there was a noted die-off in Bighorn Canyon and Mountain Mahogany, and the park wants to know what was happening, what was going on, and we're actually doing a research study on that now.
So do you have any conclusions on what the cause was?
That's what we're working on that right now. So it's possible that it's drought related, but there's also been tent caterpillars, and the tent caterpillars have been really invasive, or have shown up a lot in that area. So, and there is another study that just came out looking at the interaction between juniper trees and mountain mahogany, and if junipers have invaded too much, it can outcompete the mountain mahogany. So we're looking at all of those things. And then looking at our high elevation Alpine site. So this one's kind of cool because this happens across the world. So we follow the same protocol that other areas, other countries are following, and that just in the past probably 5 years, there's now another 2 additional sites that have been added in the greater Yellowstone. So we have a site in Yellowstone, one in the Beartooth Mountains, and then one on the eastern side. You know where that? It's somewhere. I'm sorry, it's on the western side of it. Yeah, in Idaho, I think. So, and it's cool because we're getting the Lemhi range. Yep, thanks. We're getting a lot of information about the vegetation on sites, but also like lichen species. So, and we look at soil properties, and we've only been to the site twice now, so it's hard to make any, like, have things changed or not. We go every 5 years to study this. So we started in 2011. The next time we'll go will be 2021. And this one, it's a beautiful site to go to. So there you go.
So our water resources program visits all of our park units, and you can imagine things are very different in Bighorn Canyon, sort of more eastern Montana, than they are in higher elevation parts of Yellowstone and Grand Teton National Park. Regardless, climate is influencing conditions in all of our river systems. So generally speaking, here's a summary from the GYE. This was led by Robert Alchokachi. What we're seeing is earlier onset of peak flows. We're seeing lower minimum flows, summer minimum flows. We're seeing less ice cover on our river systems. And a lot of that change has become more pronounced in just the last 4 decades. So this is a really cool study. Robert then tried to translate how those flows may affect native fish in our region. Another project that we were working on that I just want to highlight is a Soda Butte Creek project. There was a big abandoned mine just outside of Cook City. That mine was leaching heavy metals into Soda Butte Creek. Soda Butte Creek then runs downstream into Yellowstone National Park and ultimately into the Lamar River. Folks here at MSU had studied that system and helped characterize the downstream impacts. In 2014, a colleague with Montana DEQ completed a cleanup of that mine site. The announcement was made. I saw Tom at a meeting. He said, we need to monitor water quality after the cleanup. So in fact, we did. And we worked with Montana DEQ to design a plan that would allow us to formally evaluate not only the cleanup, but there was an impairment listing, a Clean Water Act impairment listing on that stream. So we developed a study plan, a monitoring plan that would allow us to address that impairment status. 2 years fast forward, we did our field work, we submitted the information, and that Soda Butte Creek has now been delisted. So water quality has improved sufficiently that we're not getting measurable levels of metal in Soda Butte Creek. It's the first abandoned mine related delisting of a water body in the state of Montana. So a huge, huge success. We went back in the fall of 2018 and we did some macroinvertebrate sampling. I won't bore you with the details, but essentially we were looking at richness metrics upstream and downstream of Soda Butte Creek, and there's no measurable difference now in the bug community upstream and downstream. If we would have looked at a thesis done by an MSU grad student in the 70s, there were no downstream of bugs. So metals were occurring at such a high concentration that were toxic to not only fish, but macroinvertebrates. So a real big success story, and we celebrated that this summer. And then ultimately, you can imagine in these high mountain streams, the water quality is very good. And that's great because some of our National Park Service waters are designated outstanding natural resource waters. The Snake River is a wild and scenic river. And so we would expect high quality waters. We'll continue to monitor those conditions in the rivers to see if things change. But the other thing that's really interesting to watch is how dynamic those river systems are. So, you know, when we get a big spring flush during snowmelt, we get changes in the concentrations of sediments, but also some metals related to sediments. And so it's fun to sort of untangle the relationships in our water quality that we see in the different river systems. And a lot of it is related to the timing of flow or to the contributions of groundwater. So the next thing that I work on is our amphibian and wetlands vital sign. Most of you have probably heard from the news, amphibians are the most imperiled taxonomic group on Earth. So no surprise, Yellowstone and Grand Teton National Park work with scientists to identify amphibians as a vital sign. We have extended that vital sign to include wetlands because this is the habitat that amphibians use around here. They're not using Yellowstone Lake in the same way they are using a small isolated pond or a wetland. So what have we learned or what have we confirmed? Wetlands are indeed among the most climate sensitive habitats in our region. So in dry years, we see wetlands drying prematurely before frogs can metamorphose. But what we've also learned, which is sort of revealing and interesting, is that the sensitivity of wetlands varies by subregions of the park. So what we've learned is some of the lower elevation parts of the park, despite being connected to groundwater, like the Beckler area, are actually really sensitive to increases in temperature. And so this sort of sub-regional analysis has allowed us to inform managers of the most sensitive places for amphibian breeding in parks. Another thing we heard about in the early 2000s was that amphibians in Yellowstone were declining and tanking. And there was a study that was published, co-authored by an MSU professor. And in fact, what they did confirm is that wetlands were drying and then amphibian numbers were down. That study also, though, was conducted at the tail end of a 7-year drought. And so what we have seen through time is some of our species sort of climbing out of that. We're still having dry years, but we're not having 7 dry years in a row. And for species that only live somewhere between 6 and 13 years, 7 years in a row with no recruitment because of dry wetlands is tough on amphibian populations. But we are seeing relatively stable numbers and slight improvement for some species coming out of the early 2000s drought. Another really cool thing that was discovered in Yellowstone, not by our group, but by park biologists, was a new vertebrate species. Spadefoots were in the region, but plain spadefoots had never been formally described in Yellowstone National Park. And just in 2014, spadefoots were documented at a single breeding site in Yellowstone National Park. Yellowstone is really well studied, incredibly well studied. So to document a new vertebrate species in the park is a pretty interesting story. So landscapes, I won't go into great detail here other than saying that we know that parks are isolated in a sense, by their borders and by the way they're managed, but they're not islands. And things are changing around parks. Things are changing in the landscape. Climate is changing. Home density is changing. Invasive species are coming in and so the Park Service understands that, and they've got monitoring protocols in place to document the changes around the parks. And then climate. I can tell you that in early 2000, climate probably not one of the most important things that came up in what we know is climate is a really important driver for everything, and everything that's being monitored in the parks. And so one really cool resource by our collaborator, Mike Tersic, is climateanalyzer.org, where you can go to a single location and you can download snow-tell information, weather information, stream flow information, fire information. And so it's a great portal. He's also got a lot of canned graphics in there, so you can sort of tailor your interests at a particular location and create some graphs. And it's a really great resource. Or you can just, it's a great way to pull the data without having to go to multiple websites and find information. So this is a great resource for our region. In terms of some of the other high-level things we know about climate in the region, temperatures are increasing, both maximum temperatures and minimum temperatures. The minimum temperature is probably the biggest concern because that's probably what's driving snowpack loss. Where is temperature increasing the most? It's on the shoulder season. So it's increasing in the fall and in the spring. And in fact, March, we're seeing the highest rates of increase relative to our historical record in the spring, in March, which means earlier runoff and probably changes not only in the timing of high flows and rivers, but phenological changes biologically that we're not sure how those will manifest at this point. So yeah, snowpacks are declining. Greg Peterson with the USGS did a great publication on that for the entire Northern Rockies. And some of those numbers are really scary. Some of those forecasts are very scary. Here's what they look like if you look at them graphically. So this is April 1 snowpack, right? This is our water producing snowpack. April 1 snowpack, summarized 1915 to 2006. Here's Yellowstone for those of you who don't know the footprint. Here's the greater Yellowstone ecosystem. Here's Grand Teton National Park. So those are historic trends. This is what April 1 snowpack is projected to look like 2030 to 2060. And this is what it's supposed to look like by the end of the century. So it's pretty alarming. And those species that are dependent on those spring runoff from snowpack are likely to respond to these changes. And you know, we're poised in some cases to be able to monitor that change. There's other ways to express how temperatures might change. Here's Moose, Wyoming, headquarters for Grand Teton National Park. And here's temperatures, I think average annual temperatures plotted back to turn of the century. And here's two forecasts. So one, business as usual forecast, that's what temperatures are going to do. And one, if we actually start to correct things. Both show increases. What's the scale of the increase by 2090? Well, Moose, Wyoming could feel a lot more like Rawlins, Wyoming. Or if we don't change our ways, Moose, Wyoming could feel a lot more like Cheyenne, Wyoming. So we're trying to keep, we try intentionally to keep this very high level. And so we wanted to, as we sort of distill this, remember our charge is status and trends. We're supposed to tell you how resources are changing and their current condition. But we're realizing that's only part of the story. The other things we're learning along the way are how our vital signs are responding to meteorological conditions that can change from year to year. We can have a really dry year and a really wet year. Understanding how our resources change in those conditions allow us to apply that information to forecasts. Climate matters. Climate matters to everything we do. Our recipes didn't include climate explicitly when we started in the early 2000s, and now they all do. Because in national parks that are pretty well protected, that's a big driver of change. Coordination is key. We're a small group. There's 6 of us. So the work that we do every year is really dependent on our partnerships with university faculty and graduate students, NGOs, our interns in the summer. And so coordination, coordination, coordination. And then communicate. It's great if we know this stuff, but if we don't share it with decision makers, if we don't share it with our partners, and we don't share it with the public, then we can't do anything with the information. The communication for us is key. This is our coordination slide. This is re-releasing native fish into Soda Butte Creek after the cleanup. And so we've got a Park Service biologist working next to 2 state biologists and a Forest Service biologist. So just a great example of coordination. So climate matters. How does it matter for whitebark pine? We know, for example, mountain pine beetle that used to have a multi-year life cycle. Once they exceed a growing degree day threshold in a given year, like in 2006, 2007, and 2008, that multi-year life cycle gets compressed into a single life cycle and they can do a whole lot of damage. So the really dry years of 2006, 2007, and 2008 were good for mountain pine beetle and bad for whitebark pine. We can see we had some cooling, so the cumulative growing degree days in subsequent years were such to suppress those beetles again. But in 14 and 15 here shown on the graph, we had again warm years. So beetles were able to go from that multi-year life cycle to a single. So not just whitebark pine is correlated to climate, but all our vital signs, we see interesting patterns with climate. Our projections, knowing that things are going to get warmer in this area, suggests that there is going to be future change. If we're not seeing trends now, we should anticipate some trends and changes in our vital signs. We also are working really hard with our park partners to make sure all the decisions they make on the ground are climate informed. Because this is the biggest driver for many park humans. You know, Yosemite is on fire. That place is fundamentally different today than it was 100 years ago, and it'll be fundamentally different in the next 100 years. So we're using all kinds of different tools. David Thoma in our shop, who's not here today, who's way smarter than I am, he's using Google Earth Engine and to look at NDVI time series. So he can look at 2007, which we know was a drought year in our region. I'm looking at individual wetlands on the ground, and David Thoma is taking a bird's eye view, and he can show that July soil conditions throughout the GYE were dry, were incredibly dry. This red is relative to the 2000 and 2018 average. But even though this is dry, we do see places in the landscape that still have moisture. And so what's really interesting is to try to understand the kind of variation we see in what's persisting in dry year, how organisms are moving in response to those conditions. The flip side is a wet year, like 2011. And again, it's a wet year, there's a lot of soil moisture, and so from satellite, the GYE is pretty green. But even within that matrix of green, within that sea of green, we're still seeing some pockets of dryness. So this is a really great way to look at landscapes, and very different, fundamentally different than the individual wetlands that I visit in a given year. In a dry year, the 330 wetlands that I visit, 40% were dry. So that has impacts to wetland-dependent species. In a wet year, just a few of the wetlands that I visit are dry. But anyway, David Thoma is employing tools like this to really allow us to look at entire landscapes. We're also using tools in our photo monuments of wetlands to try to understand ecological thresholds. So I can take a long-term runoff, snowmelt runoff average for an individual site, and I can plot that as my zero line. And in a year where I have runoff that exceeds that long-term average, I've got a blue dot. And in a blue dot, like in 2008, I've got water in a wetland. In a year where the runoff was below the long-term average, like 2007, where it was well below the long-term average, we have a dry site. So we can combine our climate information with our on-the-ground measurements to develop ecological thresholds for individual wetland sites. And that's pretty cool stuff too. And it's using different tools that weren't available when we first started our monitoring, but it's also relying on this photographic evidence and this photographic history, which is also important today.
Keep going.
So the big picture. Coordination, coordination, coordination. We work with our partners. We do everything we can. We work with students. We work with anyone who's willing to go out with us. Scale matters. We ask a lot of questions, and scale matters. The answer to those questions matter depending on the scale that you use. Kristin talked about whitebark pine. We visit those plots once every 4 years. Our wetlands, we visit them every 1 year. For a plot that we visit every 4 years, to develop a time series where we're looking at the differences among meteorological conditions among years, it takes us 4 times as long to acquire the information that we do in a amphibian data set where we visit the same place every year. So we have different goals, different strategies, but we need to always be mindful of temporal and spatial scale because it really does matter in terms of how you answer. The other thing I mentioned earlier is communication and outreach are really important to us. And then we're going to touch on how we contribute outside of the field work and the reports and summaries that we do. So coordination, here's a picture of the GYE again, the Greater Yellowstone ecosystem. Yellowstone and Grand Tetons sit at the core, but animals are moving and invasive species are moving across boundaries. So it's important that we're always working with our agency partners. We're also integrating information across vital signs. So we talked about the fact that we monitor whitebark pine and we monitor climate and amphibians. We're constantly looking for ways to integrate the information to make sense of what we're learning. We think coordination is essential because it allows park managers, land managers, biologists on the ground to prioritize our resources and minimize redundancy. If we're all doing the exact same thing with limited resources, we're not being as effective as we can in monitoring the health of the greater Yellowstone ecosystem. We also like working together because it allows us to co-create solutions. Nobody's neck is completely out. We're working together to come up with strategies to get the work done. And if we're working together, it allows us to raise awareness through a common voice. And Andy Hansen and the ecology department proposed last year in a paper a vital signs scorecard, and something that we would all contribute to. All of the folks that are on the ground monitoring, we contribute to the vital signs scorecard, and it would be released every year, and the public would see how we're doing with respect to all of our resources. Scale matters. I just talked about scale. We probably do everything from local to national. Haven't done a ton of global work at the moment, but what we would say, for the most part, our sweet spot is the regional scale. Probably the most biologically relevant scale. It's the justification for working with clusters of park. It's why people in this area work at the scale of the greater Yellowstone ecosystem, because animals are moving across boundaries. We can do local scale work. Here's climate information. This is a drought index at Mammoth. That'll probably tell us something about conditions in the terraces or in wetlands around Mammoth. But there's also a reason for using, for example, our CO2 record to understand change. And this turned out to be probably the most globally important data set on Earth. And so as we think about our work, it's important to think about how relevant our information may be into the future. So how do we communicate? How do we get the word out? So we do your sort of standard multi-agency reporting and Park Service and multi-agency reports. We publish papers. We also feed information into data visualizers so that users on their end and from home can take our information and make summaries from it. We also, I say we loosely, our partners work with us to get stories out to the popular press, everything from National Geographic to the Bozeman Chronicle. We also understand the power of social media and things that people are really consuming, because they're not consuming ecosphere articles in the way I would hope they would, right? So we work with folks to develop park videos, podcasts. We're working right now on an update to the Amphibian Field Guide that was first published in 1995. We share information in the form of classes with our partners at Yellowstone Forever. Aaron Shanahan, our colleague, is working right now to develop a special issue for a Frontiers for Young Minds special issue. So targeting, I think, K5 through 12 students with science stories from parks. So we're doing everything we can to share information on park resources, and we're lucky. People care about national parks. And so it's fun to share these stories. Okay. And then most recently on the table here, we've got some vital sign reports. So there was a State of Yellowstone Vital Signs report that was released last year, and in it is a whole catalog of the vital signs that we monitor and their current condition. We also just published a special issue, and so there's stories on a number of vital signs. And in a nutshell, what did we learn? What were the major themes that emerged from the Yellowstone Science article? We need to monitor more vital signs. We need to expand our programs to the extent of the GYE, so they're not just in Grand Teton or Yellowstone. And then, just like Andy Hansen's recommendation and ours earlier, we've got to regularly communicate our information with the public. Yep, cool.
So a lot of great information coming in, a lot of ways we can get our information out there, but we can do all of those things, but if it's not being used or isn't being grabbed hold of to help managers make decisions, then it doesn't really matter, I guess, what we're doing. So these are some examples of how we've contributed to kind of that whole system and that process. So the information we're collecting goes into our on-the-ground data, goes into decision makers for conservation action. So we're part of the White Bark Pine Interagency Working Group in the Greater Yellowstone ecosystem. We're able to inform those land managers what's happening with white bark pine, and then the further we delve into our data to help them understand more about even like places they could plant the trees, like small trees for recovery of white bark pine in places that have been hit. Andy mentioned the Soda Butte Creek delisting. We've talked about climate smart conservation, and then just in park planning, we'll often get phone calls from parks about like what's happening and what information do we have available to help inform them as they're making decisions about even road corridors and repaving roads or rebuilding bridges. We've done a lot of exchange of information in our experience. So one example is with Mongolia. I got the opportunity to go over to Mongolia on a site visit and work with national park staff there. And it was really cool, just a very simple tool that we provided them, which was a way to more clearly record wildlife sightings. The park superintendent was able to use to inform how many Argali sheep were in his parks. So something simple like that was really awesome to hear about them being able to use it, and just a formal sharing of information back and forth. And then we also, again, Andy hit on just kind of the numerous approaches that we've been using time. And again, really, as we learn more about how to use climate information and applying it to what we're learning, both within the vital signs that we monitor and then just as a whole, we're becoming more innovative in how we're using climate data and informing the decisions that are made. We're also doing like testing of new tools. So eDNA is an example of, going to a wetland, and if Andy doesn't see amphibians in the site, but we were able to collect water samples, we'll learn more about what amphibians were present. Google Earth Engine coming online. Andy had highlighted that with that red and the Christmas slide of what was dry and what was not. High resolution imagery too. So again, a lot of cool things are happening, and like our white bark pine protocol, our recipe for monitoring white bark pine, was picked up by the BLM, and they're using that to do white bark pine monitoring on their own sites. Upland vegetation protocol is being used we actually borrowed it from the Upper Columbia Basin Network, and so 8 parks are using that exact same protocol, which is super cool because then we'll be able to do our analysis across all those parks will be simpler in the fact that we're collecting data the same way. And the amphibian protocol being picked up by other areas such as Klondike Gold Rush National Monument, and that's up in Alaska, and then the Bridger Teton National Forest, so even in our backyard. So it's cool to start to see how this stuff is getting used. It helps us be more motivated, and not that we're not passionate about what we do, but when we start having the stuff used and the conversations going back and forth, it really helps us become better at the task and answering questions. And then this is like opportunities. So we have a lot of internships work with us every year. And so there's opportunities through even just coming out on site with us. And then opportunities for analysis. We work often with university staff to help us with different analysis tasks that we just don't have the skill sets for. Special projects and even graduate project ideas. So, and then there's always the opportunity to volunteer, and specifically iNaturalist, that's the online thing that is being used to document where amphibians are occurring throughout the Greater Yellowstone ecosystem. So it's an app you can download on your phone. You see an amphibian, you can take a photograph and you load it up, and it gets confirmed by herpetologist specialists. So, and that's it. That's our presentation. So, thank you. And opportunities for questions.
Just a note, I'll point to their microphone, just so if you could turn it on if you have a question, that'd be great.
Of all the vital signs that you're collecting, which ones do you find historical data going back the furthest that you could compare 50 or 100 years?
That's a good question.
That's a great question. So We're very fortunate in our region to have USGS gauging stations that were on the Yellowstone River and the Lamar River and the Madison River. I think the Yellowstone River, they started monitoring flows at Corwin Springs at 1897. Lamar is about the 1940s and Madison about 1910. So those are pretty old records. And you know, when budgets get squeezed, we often have conversations about what to let go. And boy, data sets like that have such a legacy, it's easy to say no way, right? But those data sets are being used now in ways they couldn't have imagined in 1897, right? Documenting ice cover, you know, so the ice record on those gauges, I think that was just because they couldn't get a good reading on those gauges, but now that ice information has turned out to be pretty valuable. So that's an old one. With PRISM gridded climate data, it actually goes back to, I think, 1900. You know, that's interpolated information, but that's an interesting historical record. There are some weather stations in Yellowstone that go back. I think the Mammoth weather station goes back to about 1900. So those are some cool cool physical data sets. In terms of biological data sets, there was some monitoring on Columbia spotted frogs that was done, I think, in the 50s. Fred Turner's work, and a colleague of ours has revisited that. But those historic biological data sets are harder to come by. Great question, though.
Is there a coordinated way to access data on human activities also, like hunting, fishing, construction, you know, driving, hiking, that sort of thing, so you can see, you know, maybe correlate this with some of your vital signs?
Yeah, so the Park Service does track like visitation to the parks. And so they do have a way to do that. In a place like Yellowstone, they also do like creel surveys or fishing activities. So there's going to be historic records of that, but it isn't a strong enough record right now. And there's like backcountry use measurements too, but we haven't ever taken it to kind of correlate between. A lot of our sites are more remote and are off the beaten path. So we're not going to have a lot of overlap with visitation or visitor use, except for maybe at some of the water quality sites. But for the most part, we are like separated from that.
But you're showing maps with a lot of, you know, I don't know what the spatial resolution is for the greater Yellowstone ecosystem, but you're covering a wide area.
Yeah, so there isn't a strong, once you get out of a place like Yellowstone or Grand Tetons, I don't know, I'm less familiar about what the records for like the Forest Service are.
And in terms of visitation, the annual park records are probably as good as we have, just from the. Yeah.
And there's a lot of research in the parks about like how people move around in the park. And so at some point, if there was interest, we could look at that.
Find some of the limitations to be frustrating, like no drones, no.
So we work through the process. If we need to install equipment on sites, we work through whatever research permitting process there is. And we have never been told we can't install something to do the work that we are doing. As far as like drones go, again, there's a process to go through that. We haven't had a need yet to use drones. I know other networks and other park units are actually exploring options for that. So it can be considered red tape, but we work through it however we need to. So yeah. Other questions? Come on out, come volunteer, join us. So thanks.